So yeah, switching gears a little bit. My name is Jay Kim, and I work for a company called Apex Labs, and we're going to talk about wearable displays and smart glasses, hands-free personal displays, and how share some of our experiences in having been in the space for almost 5 years now, exclusively focused on introducing smart glasses into the enterprise environment, and share with you some of the things that we have learned and also would like to hear, some of your experiences as well as a result of maybe a panel discussion later on for those of you who have looked into it. Lots of opinions are certainly out there. Real high simple personas: build, fix, move, operate, people, things, goods, what have you. These are scenarios where people are constantly having to work with their hands, and this is the whole notion behind smart glasses and hands-free, right? Is you want to, you want to target ideally use cases and roles of people who are constantly working with their hands, and therefore having access to information that's heads up and having an interaction model that is mostly hands-free, and emphasis on the mostly because I'll cover this later on, are high value and important. So from a business perspective, we've gone kind of across the full horizontal enterprise spectrum, but have converged over our years of experience across these four high-level personas: people that are building, fixing, moving, and operating. Let's go right to the state of the art of where things have been so far. We've learned over the last 2 to about 3 years, there are very two distinct categories in head-mounted displays as it relates to augmented reality, leaving out the virtual reality part for a little bit. There are two categories that are emerging. One is a heads-up display to the tune of a Google Glass or the Vuzix M100, along with a handful of other kinds of devices from smaller companies that are really intended to be lightweight, embedded for the most part, and based on micro interactions, so bits and pieces of data that's not necessarily visually enriching, but it's giving you some information that is meant to assist in the task that you're supposed to do. Text, iconology, some of the displays that we have seen that are very, very lightweight are monochrome, and in some of those instances that's actually okay. So this is going to be a little bit of a distancing from some of the holistic textbook AR kinds of use cases that we've discussed so far today. And then, of course, you have on the other end of the spectrum AR glasses that, that's the holy grail. That's, you have full, ideally very immersive, 3D displays that are stereoscopic that have the capability of being able to deliver visually enriching data and content. It has the potential for sure of being able to deliver a very natural experience, but there are many nuances as to why that hasn't quite materialized yet. But along the bottom of the screens, these are devices either are in production and have been for some time, and you also have devices like the Microsoft HoloLens that has been just announced and starting to get some feedback from the broader community on the potential of what it can do. And of course, also represented here is a daiquiri product, an area member product called the Smart Helmet, which I'll also discuss it as well. So within these two different categories, you're also seeing some diversity that's starting to form. And what that means is that really this kind of, this generation of HMDs itself hasn't been, it's not a new concept. It's existed in various forms dating back to the 60s and 70s, starting with some of the glass cockpit and some of the heads-up displays that fighter jet pilots used. But where this is going is that there is an order of magnitude, actually multiple orders of magnitude in cost reduction, reduced complexity of different devices, highly integrated circuits and systems that are driving basically the use of embedded, fully embedded devices that are wearable. So from a first generation standalone HMDs that are out there that have the ability to self-power, process, visualize, and also sense the environment, we started really seeing that diversity start to form from 2013 and onwards. And that diversity continues to go on today. And then manufacturers that have had traditionally product in the market in the 2013 timeframe, 2014 timeframe are starting to introduce their second generation or their Gen 1.5 type of products. So there's movement from the existing players, the incumbents, and the new players that are jumping into the space that are investing in the category long term rather than introducing a product and kind of letting it flame out. And that, from an industry perspective, that's pretty significant. That there are signs of this being a self-sustaining kind of driving its own momentum type of a category. You're also seeing consolidation start to take place, and also some of the venture capital activities that are going on across the world. The most notable, of course, is a news that's about 2 weeks old. A company called Recon Instruments, which wasn't really in the enterprise space, but was one of the largest manufacturers of HMDs, just got acquired by Intel, who has been investing heavily into this space for $175 million. So the price tags and a lot of that, and when the floodgates open as far as a major exit of this kind of magnitude goes, and in the technology industry, that's when also capital starts to flow. So there's a lot of goodness that's happening in the space right now. So let's talk about the two popular approaches that we at Apex Labs have seen, and that's this whole notion of a smart personal protective equipment. Two different categories again here: smart safety glasses and smart hard hats and helmets. And they share the one thing in common, that both of them target personas and use cases and portions of the workforce that are wearing the dumb versions of these two things. And that's where we've seen the best kind of reception towards something like this, because again, the theme here is crawl, walk, then run. So you want to be able to introduce new technology and inject that within the process, which has been a concept that's been touched on by several of the previous presenters, to make sure that you're not inducing disruption. You're gradually introducing change and making sure that you're controlling the number of variables that you're introducing in a given environment. Because unlike a lot of the innovation projects and a lot of the pilot projects, if the goal is to have this technology hit production environments, you have to be very, very, very deliberate about it. So within the safety glasses, eye protection, kind of obvious. A lot of the activities that we have seen on this is on the manufacturing lines, warehousing, plant ops, oil and gas labs, and mobile network operators is another area that we've seen a fair amount of activity targeting the smart safety glasses. There's a certification requirement, so there's a minimum barrier of entry for the hardware to be deployed within that space in a production environment. And the most nuanced part, which really separates this from a smart helmet type of an approach, is that because it's a set of frames that you put very close to your face, unlike a helmet, there's an additional layer of complexity that involves personalization. It may be that prescription eyewear, just like the ones that I'm wearing, and people have different kinds of head interpupillary distances and lots of physiological types of features that you have to customize the smart glasses offering when it's worn in a safety glasses format. Hard hats, on the other hand, not to trivialize the amount of complexity and the personalization associated with it, but generally speaking, for the environments where hard hats are required, it's there is a reduced need for a lot of customization, because helmets really fundamentally fit over the top of your head. And of course, you have to have different sizes that go with it, and there has to be some adjustability of the display that is put in front of you. But you can address a larger portion on a percentile basis of the population with fewer products. So from an adoption perspective, there's some benefits to the helmet as a form factor. Never mind the fact that it's a lot easier to balance your weight on something that kind of goes around your head rather than doing it really around the 4 points, and that's on the both sides of your nose and then on the sides of your ears. So potentially more sensors, more battery life, and potentially a lot more capability as well. But of course, from a larger, broader demographic perspective, there is a larger portion of the world's workforce requires only safety eyewear as opposed to hard hats. So two fundamentally different kinds of personalities. And the next slide is going to be an area member video.
In this case, you can see 3 work cells are clearly labeled with their
Who recognizes
status
his voice?
and associated data points. Here, the smart helmet helps the worker identify that cell 2 is in need of attention and is at risk of the loss of the batch. Had the worker needed to go to an offline system to look up the work cell data one by one, it's possible that a critical window could have been missed and the entire batch would have been wasted. At this point, the worker goes to the hopping chamber to perform that critical task while there's still time, and the smart helmet guides him through the steps. The worker then selects the camera from the menu on the smart helmet so that he can make a quick recording of the completion of the step that he's just undertaken. Once the task is completed, it captures an image to record the completion of the step. Having completed the task and alleviating the potential emergency by performing a time-critical action, the worker now has time to open his tickets and close out the associated task, adding hops, and move on to the next task, continuous fermentation. At this point, a timer appears, letting him know just how much time he has to complete that next step.
So you could do this using a handheld device. You could do it using a tablet. You can do it using other kinds of mobile devices. Heck, you can even do it using a computer if you so wanted to. But this is all about targeting that specific person and understanding what is the right tool that actually works the best for the task that he or she is doing. And even from some of the background graphics in that video, there are some significant benefits of being able to go hands-free, whether or not it's from the perspective of an uninterrupted workflow or making sure that there are basically passive activities that you're doing. So if I choose to reach into my pocket and pull out a phone or a tablet, this now is a deliberate effort that I have to make, as opposed to if you're having if you're wearing a hands-free device and a hands-free display, something like a smart helmet, you now have activities that can be driven by some of the broader environment that is around you. So here you saw some glimpses of the concept of the industrial internet. You saw a convergence of smart glasses with other kinds of smart glasses or smart wearables like smart watches. So really what we're talking about is a use case that can be used, that could be applied today, and then sometime in the very near future that converges on two very large concepts, IoT and wearables. So from our perspective, and based on the lessons that we've learned, there's been two tales of AR, assisted reality and augmented reality. I won't go too deep into the definitions of both because I think it's been covered in the past, but we have learned that as an initial project or initial way to introduce this kind of technology into the enterprise, we have had fewer roadblocks in going with the left side of the column, and that's the whole notion of assisted reality. And the reason for that is simple. There is a larger and oftentimes less expensive offering of hardware that's out there. So from a wearability and from a broader user applicability perspective, we're simply able to offer more devices, although that is changing very, very soon, to fit the different kinds of needs of the user demographic. The information, and this is key, the information that is being delivered to the workforce, there's a significant chance that already exists within the enterprise IT ecosystem. You know, these are systems that companies have spent millions of dollars, in some cases billions of dollars, and decades of time building out, their specific workflows and their information. And what we're doing, starting with these kinds of pilot projects, is making sure that we pick that up and we deliver that to the person that's doing the job, and right at the place where the work is being done. Augmented reality, on the other side, has a content layer complexity. We talked a lot about preparing data, authoring content, and making sure that it's all there. But let's assume for a second that many of those people, many of those companies, have not taken that leap yet, and they still want to experiment with this kind of technology. If we're all playing the long game and assuming that this is a project that is going to take months and years to really get to the full production scale where these things become ubiquitous in the workplace, you have to start somewhere. And you certainly don't want to start until the content piece of the problem has been solved necessarily. So it's been a nice way for us to get a very quick call to action, and making sure that we're providing a long roadmap from an operations perspective. Again, this isn't a technology problem, as Carl was saying. This is an operational efficiency problem that AR and wearable devices are acting as a means of solving. So we've started with providing connectivity hands-free to the ERP. Let's talk about some of the variables that exist. And the first one, of course, is the human factor. Who's worn smart glasses? Show of hands. About 2/3. I imagine you did this all within the context of looking at it for work. So it's unlikely, based on where this is going right now, that this is a technology that's going to be introduced in the household or at Best Buy or whatever the equivalent of Best Buy is in the UK. You're going to experience this at work. And that in and of itself is going to create a lot of confusion, and there's a huge training factor that comes in. There is a user engagement factor that also comes in as well, and the whole paradigm of how this is being used in the workplace still has not been fully defined. The most significant bit actually is the user interaction model, which is at the very top of the minds of the companies that are deeply immersed in the space. In an environment where most people's interaction with data has been on touch gestures, and now you've got kind of this floating screen that is in front of you. Is gesture the right way to do it? Maybe. In some of the cases, it sure can be. But there are multiple nuances that have to go into it. Low barrier of entry, we already talked about this. Privacy concerns is another. A lot of these, and this has actually been a constant across the consumer and the enterprise, is that a lot of these glasses and a lot of wearable technology in general have the capability of recording a lot of data about the people that are using it. And how do you mitigate some of those privacy concerns so that that this doesn't end up becoming a policy issue? We'll talk about that in a little bit. And the pilot cases, we've learned, should try and include as broad of a demographic as possible, but with a slight bias towards some of the less skilled workforce that are using it first. And one reason for that is that, generally speaking, they are more familiar with new technology and mobile technology, but the other part is that the younger portions of the workforce also tend to get they tend to generate, because of their lack of experience, they tend to generate higher return on investment. On the technology factor side, data, already talked about that. On-premise integration is where we have seen a lot of these kinds of things start to happen. The cloud is a great concept, and a lot of people are actively working to move at least portions of their infrastructure there. There's a prevailing thought that some of the glasses and the wearable technology infrastructure can be moved off to the cloud, but again, if the legacy ERP systems is what you're trying to integrate with, it doesn't make a whole lot of sense to have the interface to that legacy enterprise backend, which, by the way, in most of the cases reside on premise, to move that up off into the cloud. Most of the times, no. Not today, anyway. And then from a connectivity perspective, maintaining good wireless connectivity so that you're not bound to use cases that require a constant connection is also something that we have had to spend a lot of time making sure that the product from a hardware and a software perspective, so the whole solution, is robust enough to be able to handle. Device, already talked about this, and of course the IT integration. These are problems that are getting solved today. And frankly, the technology part, as far as getting to a minimally viable product for the enterprise, is actually the easy thing. It's the human factor, and the next thing that I'll talk about, which is the policy factor, which are some of the difficult problems to solve that's going to take a lot of advocacy and a lot of time, not just by the providers, but also working in lockstep with customers, research institutions, and academics to try and figure out. Security has been something that's been a big deal. Wearable devices are even more mobile than mobile phones and tablets. You can inconspicuously, maybe not the smart helmet, but smaller things like watches and some of the really sleeker smart glasses devices. You want to make sure that there's some minimum layer of security, because so much of the information that the glass is showing are workflow information that can be sometimes a trade secret. You certainly don't want that leaking to a competitor of yours or just out into the internet. That is a big driving reason as to why so much of the enterprise backend systems are still residing on premise, because physical security has been very, very important. So there's an element of the physical security, and then the logical security of having software hooks and infrastructure hooks. And it could be a solution level hook where your devices are dumb if it doesn't authenticate into your wireless network of choice. Making sure that those things exist today prior to these things even hitting the production floor, frankly, from our perspective, has been one of the more onerous problems to solve from a time consumption perspective. It's been a resource sink. Privacy, again, top of mind. And one activity that's starting to happen is that there's interest in having basically third-party audit houses that come in and do a lot like how some of the cybersecurity firms are coming in and doing security audits. There's an analogy that's also happening from a privacy management perspective that's being undertaken by many of the same cybersecurity firms that are coming in and doing audits. It's coming in and saying, if you were to use this device across these kinds of scenarios, is there a possibility that your personally identifiable information is going to leak? And making sure that any kind of analytics that you're collecting at the user level is anonymized to be able to allay some of the concerns of, for example, when you're working with labor unions and relations. Because the last thing you want the workforce to be able to say when you hand them a device is, what is this collecting, and is what is going to be collected potentially going to be used against me? And if you don't have a clear answer as to how you're going to drive that strategy, that could be a real pitfall, because user acceptance at the end of the day is everything. Ideally, from a policy perspective, you want glasses and you want these hands-free displays to become a required tool that is used, a lot like torque wrenches, voltmeters, and different kinds of environments. You want to make sure that you get there, and you provide a path for you to get there. Training and support, Mark did a real good presentation on it, but it has to be a day one commitment from the companies to make sure that this no longer ends up being just a technology or an innovation exercise, but there are operational groups that are really cross-company that are committing to this across all the different facets of this kind of technology deployment. And then labor relations, I touched on this a little bit. We can look at this a couple of different ways. One way to look at it is this technology going to now drive so many productivity gains that it's going to eliminate my job? And the answer, of course, is no. By being able to drive additional productivity at the individual and at the team level also means that in some of the developed countries, certainly, that there is a removal of, or there is a reduced need of scaling the labor force, and that in turn also has a lot of individual and team level job security operations. So if your plant in the UK is able to drive additional productivity, and you're able to meet the quality and the cost and the timeline targets, why would there be an impetus to try and relocate your factory to China or to Asia? So that's certainly one argument. The other argument is there is a safety component that can be driven by a lot of these hands-free displays because of either a lack of interruption, these devices being tightly integrated into PPE. So these glasses, fundamentally from a hardware form factor perspective, but also in the kinds of information that it can deliver based on all of the sensors that's available to you, it can also drive workplace safety. Is it truly hands-free? And the answer is no. Gestural interfaces, if you actually think about it, are actually not hands-free. Voice is hands-free, but voice doesn't really work in many of the loud manufacturing environments, or if you're in an environment where a bunch of people are talking, there's still a technology impediment to be able to count on a single user interaction method to be able to drive your experience. So what we have learned here is that you still have to use some of the traditional, the less hands-free, so touch-based systems, smartwatches, which was a portion of what Daiquiri was showing, and other kinds of sensors that are able to drive user input and interaction. Carl showed the slide here, but again, worthwhile double-clicking that these are the kinds of factors and criteria that we look at to guide the user and customer on what makes a good starting project involving glasses, and touches on, it's actually a nice digest of all of the different things that we have had to do. And I'll end it with a video from another area member who's, this is on their corporate website on how they've experimented with hands-free displays. And
so this whole project started, we were looking for an application for Google Glass, and when we came up to this BCA area, we saw that they were using paper instructions.
So we are currently not online for anything. There isn't computer programs to see anything. So we get actual printouts of what we're doing. And on each page, it gives us the full instructions of what we're doing to any given branch.
So when we get a packet of information, the first thing we have to go to is we have to segregate it. So each one of these is separate equipment numbers or ref deses that we have to go through. So each one of these will tell us what parts to get, which connectors to use, what contacts, and pretty much how to build the product.
built the stacks of paper.
All these paper instructions were in a database, and that initially looked fairly easy to pull that data and to create an application for Google Glass.
And the data's
so we
already
met
there.
with their manager and asked for permission to see if we could develop a project in here using our internal application development funding.
BR&T came to us with the idea of using Google Glass, and we had meetings regularly to decide what we needed on the app.
So one of the first things we decided to
Safety
ask them
hour.
is we really wanted to make sure it was hands-free. We don't want to have to stop and look down at our paperwork every time we needed some information. And the good thing about Google Glass is we just glance up with our eyes and the information would be right there that we needed.
So what the Google Glass does up here is it replaces all the paper instructions for all the harnesses. So initially the technician will put on the glass, they'll come out here and they can select which wire harness they're working on. And that dives down into which branch do they want to go to. And they can select the data for the branch, and in there are contained all the work instructions that you would find in that packet of papers for that branch. And the current process, they look up the wire number and they have to find that wire number on a plug map on paper. Right now with the Google Glass, what you do is you use a command, wire 234, and it will actually put a highlighter on where it needs to go on that plug.
Okay, Glass, start a wire bundle.
This interface has since evolved a few times after that.
Number 201.
So the whole purpose behind the internal application development of Google Glass is to prove out that glass is a feasible technology to use.
So is it universally applicable? you know, it depends. I think it's a stepping stone to be able to get to the next step, which is, you know, proliferation of augmented reality in the enterprise. But you know, this is one kind of a testimonial of you know, a large entity that started to experiment with the technology. And that's it. Thanks.